So on this video, we're going to be working with some applications of the trig functions, especially you working with angle of elevation and depression. Before we start with some exercise, I want to review a little bit here, right? So the angle of elevation, if I go from the ground right here, my angle of elevation is going to tell you exactly the same thing, right? That is an elevation. It's elevating from whatever is the line of sight or whatever is the information that they give you, the ground part, right? So this is the angle of elevation. The angle of depression, now it goes from line of sight. So say they have somebody standing up here, right? This is the line of sight, right? And the angle of depression now is going to go down. Now keep in mind that that angle most of the time is going to be actually outside of the triangle. So it's this angle right here. So again, angle of elevation is inside because again, the person is right here, standing here, and is looking up in that direction. Angle of elevation, they're looking down. Angle of depression. So this is the angle of depression right here. Now, as a review from geometry, this line is going to be parallel to that ground line. So the line of sight is parallel to the ground line. So that makes my angle of depression congruent to the angle of elevation because, so that means that this angle right here, this angle is also theta. Because if they're parallel lines, this is a transversal line and they're alternate interior angles. So anytime that we work with depression, we actually also have the angle of elevation. Again, the angle of depression is outside most of the time of the triangle. Unless I'm working with this triangle here, or I'm working with the triangle here somewhere around there, then that's it's going to be inside, but most of the time it's going to be outside. So here it says Brian's kite is flying above a field at 65 meters, at the end of a 65 meters of string. If the angle of elevation to the kite measures 70 degrees, how high is the kite above Brian's head? So if we have Brian here, right, this string right here is 65. Somewhere up here we have the kite. Right? And we want to know how high is the kite. As we're working with the height, that height, that means that this is perpendicular, so this is not it. Right? And then the angle of elevation, that 70 is this angle right here, again from the line of sight, is this angle right there. And I'm finding how high is the angle. So that means that I'm finding h over here. So based on my information from the angle, I got the hypotenuse and I got the opposite. So that means that to solve this exercise, again, I have hypotenuse and opposite. So I gotta use sine. So let's write this here. So sine of 70 degrees equals 2h over 65. I'm gonna multiply times 65 on both sides. So that means that on this case, h equals 2. I'm going to go to my calculator here and write 65 sine of 70 degrees, enter, and that should give you, that is 61.1 meters high. So number 2 says, from an airplane at an altitude of 1200 meters, the angle of depression to a building. So I got the plane up here, something like that, right? The plane is an altitude of 1200 meters. To a building. So we have the building somewhere around here, right? So this is the ground, right? So my angle of depression, again, this is height, so that's a right triangle. And my angle of depression, again, my angle of depression is going to be set out here. So this is the 28 degrees. Because the angle of depression and angle of elevation, so angle of depression and angle of elevations are congruent. That means that this angle down here is also 28. So in this case, it says find the distance from the plane to the building. I actually want to find both. So I'm going to find the horizontal distance. So it's this distance down here. Let's name x. And then I want to find the distance directly from the plane to the building. So I want to find this distance over here. Start by finding x. So x, I have opposite, I got adjacent, right? It's from 28. So that means that I'm using tangent. So tangent of 28 equals to opposite of adjacent. Right? Remember that we said that once, if I have my x on the denominator, at the end, I'm always going to have 1200 divided by tangent of 28. Right? Because if I multiply times x on both sides, then divide by tangent. So I'm going to go to my calculator. So 1200 divided by tangent of 28. And that's going to be 2256.9 meters. Now let's find the distance directly from the plane to the building. Now, on this case, my recommendation is always using the numbers that are given on the exercise, because here I did round and I'm going to lose precision. So I'm going to use that 1200 and the 28. And so that means that I'm finding from 28, I got opposite and hypotenuse. So that means that I'm using sine of 28 equals to 1200 over the distance. By solving this, again, I got distance 1200 over sine of 28, and I'm going to go to my calculator over sine of 28, and that should give you 2556.1 meters. Okay, so number 2 is telling me from a point on the ground, 12 feet from the base of a flagpole. So somewhere around here, I got a flagpole, right? And a point that is 12 feet from it. Right? The angle of elevation to the top of the pole, is 53 degrees. Remember again, this is perpendicular. So how tall is the flagpole? So I'm finding h here. So on this case, I don't have hypotenuse. I got opposite and adjacent. So that means that I'm working with tangent. So I got the tangent of 53 equals to opposite over 16, so 12. I'm going to multiply times 12 on both sides. So I got that h equals to 12. Tangent of 53. That's to give you 15.9 feet. Number 4 says, an airplane took off 200 yards in front of a 60-foot building. At what angle of elevation must the plane take off in order to avoid crashing into the building? Assume that the airplane flies in a straight line and the angle of elevation remains constant until the airplane flies over the building. So I get a building somewhere around here, right? That is 60. On the ground, the airplane is taking off from a point that is 200 yards. 200 yards is the same as 600 feet. So it's important here that we have the same unit on both of them. So there's 3 feet in a yard. So 3 times 200 is 600. And so I'm finding this angle. Right? I'm finding this angle that is here. So let's name that angle theta. Again, on this one, I don't have the hypotenuse here. I don't have the hypotenuse. I have opposite adjacent. So that means that I get tangent of theta equals to opposite over adjacent. Right? So theta equals to the inverse. In this case, I'm using the inverse because I'm finding the angle. So this simplified to 1 over 10. So my calculator, second tangent of 1 over 10, and that should give you an angle of 5.71, at least 7.71 degrees. So that means that at that angle, the plane is going to be on this point at 60 feet. So that means that it has to be greater than or more than 5.71 degrees. So then this one says a 14-foot ladder is used to scale a 13-foot wall. At one angle of elevation must the ladder be situated in order to reach the wall, top of the wall. So we got a wall here that is 13. Then I got a ladder that is laying down somewhere like that. That is 14. right? Again, this is perpendicular. Now I'm finding this angle right here, right? Like what angle? So I'm finding theta down here. So I'm finding theta down here. Okay. So again, I got here hypotenuse and I got opposite. So that means that I'm using sine. So again, I'm finding theta. So that means that I got sine inverse of opposite over hypotenuse. Going to my calculator, I got that sine of 13 over 14 equals to 68.2 degrees. And that's it for this lesson. May the force be with you.